talk about the history of photography and the camera obscura. We started off in 1839. We look at, even though the infographic is in Spanish, it's really clear that the history of photography has really changed. Um, we can see from 1839 where it was really a rich man's kind of hobby. Um, we see this gentleman here with his suit and tie, his bow tie, a vest, how large the camera is, how large the plates are. They're It can be as large as an 8 by 10. So think in terms of a sheet of paper, which is 8.5 by 11. By the 1950s, they had single lens reflex cameras. So here we see kind of like a war reporter and all the different lenses, all the different cameras he had to carry for the different size lenses. Then in about 2013, we have the invention of phone cameras, and it's so different now. Everybody's a photographer, and I included this photo because I just thought it was a really nice representation of different cameras throughout history. So here we have a film camera, 35 millimeter. We have medium format cameras, and we have large format cameras. So all these different cameras, and here's the photographer. He has them all tied together with one cable release button. And we have a wood engraving here from 1894 of large format cameras. You can see they're really large, they're really bulky, the plates are very large as well. The plate is where they record the image. Then as things change, we have the invention of smaller cameras. We have a Brownie camera. Let's see if I can find it. It doesn't look like this one has a Brownie. Oh, there it is right there in red. I'm circling it now. Well, this isn't a Brownie, but it's the beginning of, it looks like a Brownie. And a Brownie camera was basically a camera that looked about like this. And it had film already loaded inside. You could take your pictures, send it back to Kodak, and they would send you back your pictures with your camera and more film. And then here's just some from Polaroid cameras. And then here's some just more cameras and the way they look like. And you can see down at the 7th row, we have a SLR camera, a single lens reflex camera. And then some just really fun Polaroid cameras. Here is a large, like a medium format Polaroid or camera. An illustration of what looks like a kind of Brownie, and more digital illustrations. Just like fun cameras. Here's the Brownie right here, and I know it's hard to see in the slide, but this is a Brownie with a flash. And then we have an SLR camera, which here is a Ricoh 500, a twin lens camera. It has two lenses. And here's basically what you have in class, or you will be using. So we have a DSLR, which is a D for digital, SLR, single lens reflex camera. And what is a camera? Basically anything that's light tight that it can hold. Light tight box with a hole in it that records an image. The word comes from camera obscura, which means dark chamber. And here is an illustration of a painter, or he could be doing drawings, but probably a painter. And they are recreating life through the camera obscura. What does that mean, and what is a camera obscura? It's basically a hole in a dark room that reflects out the images turned upside down, and you could put, for back in the 1700s, you could trace on the wall to get a real life image that was in correct perspective. So here we see a gentleman here doing his drawing. He has a little chamber, a box. It's quite large. It's basically a hole, and light travels in a straight line. So it goes all the way straight, and it reverses and turns upside down. Here's another example of a camera obscura. You can see once again the top of this building, the circle there, the sphere, going all the way down. So we start off with C, and we go to H, and it's upside down. Remember, light travels in a straight line. You can bounce light, but it travels in a straight line. And here it is. We have an illustration of a person standing up, but it's actually upside down. And we saw this one earlier. They use it a lot for drawing, so you could have this little box, and then you could have a mirror to bounce the image up, and you could draw from life. These were quite large camera obscuras, and you can see it's not really very affordable. You're going to need money to have someone carry these boxes for you. To create these boxes, they're just really huge and big. They're great for drawing, especially for perspective drawing. They had many inventions to make a smaller version. So here we have a microscopio camera obscura for photography. It's really easy to make. You can make one your own out of a box and some tissue or tracing paper, and you just need to have a hole on the one side. You could also purchase a camera obscura. Here's one that's available that you can purchase on the internet. Or you can make one out of a simple tube. So a Pringles can works really well to make a camera obscura. And then here's the purchased one, what it would look like, and see how sharp that lens is. Back to drawing. We saw something similar before. You have a table, you put your camera down on top of it, your camera obscura. There's not a camera, remember, camera has to record light. So this is a camera obscura, so it has an opening or a lens or a hole reflecting the image upside down, bouncing straight up, hitting the mirror, bouncing up to your eye. And different camera obscuras. There's camera obscura at Stanford University at the museum there that they have on display that look very similar to this. Also the Huntington Library in Southern California. Once again, that light travels in a straight line, so we can see the light flickering of a candle, and it's actually upside down. More portable camera obscuras. And here's just some math and how it works and the angles and all these different angle views and planes. And all of the math involved in a camera obscura. There's also a pinhole information. So once again, the light enters, it bounces. We can see the light entering through the portal, going straight, hitting a mirror, bouncing down. Really common and a very good way to capture perspective and real life in person. A lot of people attribute the camera obscura to Leonardo da Vinci, but he did not invent it. He probably used one, but he did not invent it. So here we see a person in the field using a camera obscura. There's several camera obscuras in the United States and all over the world. There's one in Santa Monica. Here's what it looks like. Actually, it was moved from here to there. And the camera obscura is at a senior center. And it was at one time at the beach. So this is a camera obscura in Santa Monica. There's also a camera obscura in San Francisco. And it says San Francisco, that's incorrect. That one's still in Santa Monica. But here in San Francisco, this is what it looks like. Light entering, bouncing, and then hitting onto a surface. So here we can see the ocean, waves, and the rocks. And here's another camera obscura. They have them in a Seville. Here's the top of it. And here's the inside. Here's one in Greece. This is a 360-degree camera obscura. You can see it's a circle. And we go inside, we can see a 360-degree angle all the way around. Here's another one in Cuba. One of person who uses a camera obscura quite a bit is, and excuse me if I say his name incorrectly, Abelardo Morel. And what he does is he uses a camera obscura and he goes to locations all over the world and will project an imagery onto the wall, what's on the outside. So these are very lush locations, really beautiful locations. And we can see here the seasons changing. So from, let's go back, fall to winter to beginning, because over here we can see this is like fall, so maybe this could be spring maybe. And then here's another camera obscura, but what is wrong? What's wrong with this? Well, it's not upside down. So how did this person put it right side up? And the answer is a mirror. They used a mirror to bounce it. So here's another image. I think personally, I really like them when they're upside down. So here's another Morels upside down. This looks like maybe New York. This is for sure New York. The theater district. And then he wanted to go outside of buildings and go out into the field. So you can do a camera obscura outside. And here's another one. It's a portable trailer. And here's another diagram of how to make a camera obscura. So Morel, he made his own camera obscura and he traveled throughout the United States. So here he is in maybe Brooklyn, and we can see the bridge, but we can also see the texture in the ground. And here he is at Yosemite, San Francisco, the desert, maybe it could be Death Valley or Joshua Tree. And we can see the texture in the ground. We can actually even see the tripod. Here he is in Europe. Then we have other examples of either pinholes or camera obscura. Pinhole is a dark chamber as well, but it has one little tiny hole. Sometimes a camera obscura will have a lens. So the difference. We have Chris Fraser. He's also an artist, and he creates rooms using just slits to have the light enter the room, which is a really interesting way of thinking of a camera obscura. Point Lines Planes, 2011. So really beautiful installations of creating these rooms with light. And here's another one, Slant 2013. And we're going to see how to create a camera obscura. We're going to need, so this video isn't working, but you guys can find it on another time. So here we have a pinhole camera, which is simply a camera without a lens and with a single small aperture, a pinhole, effectively a light-proof box with a small hole inside. Light from a scene passes through the single point and projects an inverted image. So here we could use like a shoebox to make a pinhole camera. These are, you can purchase them as well. They're made out of wood. And we have the camera obscura on the left and a DSLR on the right. mentioned earlier, the camera, different sizes of cameras. So we have a large format camera, which the frame could be 4x6, 4x5 camera. It could be an 8.5 by 11, or excuse me, 8x10, or a medium format camera, which uses 120 or 220 side film. Then we have our single lens reflex camera, and in the camera we have a mirror. And then we have our simple point and shoot cameras and camera phones. And we can't forget our plastic affordable cameras as well. So these are like toy cameras. Then we have a Rollei or a twin lens reflex camera where there's two lenses in the camera. And here a twin lens camera, it has a two wide camera with, it's called a Rolleiflex. It normally consists of two equal constructed lenses with equal focal length and equal speed. They are mounted in the front. But the problem with that, with these two lenses, is that you have to be careful because we have parallax. And so here, say you're looking through the lens and you see what's in blue, but in reality, you have on your film the red area. So you look through the viewfinder and then there's the camera lens. What you see through the viewfinder because of parallax isn't exactly the same. So viewfinder in blue and the lens in red. So you think you have everything well composed, but in actuality, it's a little off. Something to be aware of with a Rollei camera or twin lens reflex camera. A single lens reflex camera, SLR, has a single lens reflex, typically uses a mirror or prism system inside. So the viewer goes through, our eye looks through the camera, it bounces the mirror, well, actually the image goes through, it bounces on the mirror, all these bouncing, and when we look through it, it's actually right side up. A digital single lens reflex camera, also called a DSLR, which is what you're probably going to be using in our class, is a combination of optics and mechanisms. Basically, it's digital. We have an SLR and a DSLR. The D's in the front means digital. Also, the slide is a little out of order, so the parallax, think about that. We do have parallax when we're not looking through the lens in a 35 millimeter camera versus what we're look through. So you don't want to chop off anybody's heads. And more information about the parallax and the parallax error and the twin lens reflex camera, what you see and what your camera sees. Do be aware of that issue. We're going to skip right through this and then go into film and film sensor sizes. So we have different sizes of lenses. The other, let's go through back. We have like a 35 millimeter. And when you are thinking of purchasing a camera, or maybe you have for your assignment to know how many megapixels are in your camera, the larger the megapixels, the larger the sensor. Inside the digital camera, we have light entering the lens. We hit an infrared filter, then it goes to the color filter, and then it goes to the sensor. And all of these happen as, light, subject, lens, mosaic filter, image sensor, all these other processes, and then finally it goes through the buffer and then to your SD card. There's quite a bit of travel of information. The sensor, the larger the sensor, the more expensive your camera and the more data and information you have. That's why you're paying so much for your camera. There's different types of filter. Here's a bare filter where the filter's on top and then the image sensor. And we're going to pass this video. Well, once I mentioned the bare filter again, the incoming light, it filters the light. So in the red area, only the red will go through in the bare part, the red area of the filter. Same thing with the green and with the blue. Here's just another example of red, green, blue pixels. But there's more than bare filters, and there's just proprietary. So there might be an Edward Chang filter, a Fujifilm filter, X-Trans, or maybe the Fujifilm EXR. There's all kinds of different filters. The other thing you want to be aware of is the crop factor on your camera. So here, more than likely you don't have a full frame DSLR, but you can see from the blue, red, and green, the larger the camera filters, or the more full frame, like if we had 35mm film, you see all this area outside the green. But as you go closer in, you can see how the crop factor. You have a crop factor of a 1.3 in the green versus the Nikon DX versus the blue area, which has a crop factor of 1.6. So if you're looking at your camera and you're like, well, I don't know what my crop factor is, or there's a crop factor, now you kind of understand. What you're looking through and what you're seeing are two different things. So if you look, and this goes back to your sensor size, we have a one crop factor all the way to 7.21 using a cell phone. Depends on your camera and your crop factor. Maybe you're only going to see the yellow area, but if you had a full frame camera, you would see the whole entire thing. Now, what does that mean? So visually, we can see a full frame on the upper left corner. I'm pointing to it, circling with my mouse, all the way down to a 1.5 crop factor, which would be this Nikon DX. Crop factors, multiply a lens focal length by the camera's factors to get the focal length of the lens, which when used as a full frame or 35mm camera gives you the same angle view. What does that mean? Oh, basically, what you're seeing with your eye is not exactly what your camera is seeing. Just kind of simplify it. So here is a comparison between a T1 and a T2 versus a 35mm camera. So you can see the crop factor. If you had a 35mm camera full frame, you would have, at 60mm lens, your actually crop factor, what you see is only 10mm. Let's go all the way down to the bottom. At 324mm, the crop factor is you're actually only seeing it's the equivalent of a 200mm. When they say an equivalent of. Then we have the anatomy of a camera. We have a lens, which allows light into the camera body, and the amount of light entering is controlled by the aperture and the shutter speed. We have tons of lenses that we'll cover in more detail in another module, but we do need the angle of view. So if you want a wide angle or a really narrowed point of view, so here, this photo was taken at the same location with a 28mm lens versus a 120mm lens. Same location, the camera doesn't change, but what does change is the angle of view and the lens used. At 28mm, we can see it's very wide, and we can see all of the forest and a little bit of the mountain. But if you were to change to a lens that's 120mm, 200mm, you'd see way more of the mountain, even though you're sitting or standing in the same location. Zoom lenses are long lenses, and here are some examples when you don't use them. So long lenses are good for portraiture. Long lenses have less depth of field and flattens the space. The disadvantages are really super heavy. Let's compare that to a wide angle, which has a considerable depth of field, and it allows you to work in close quarters. Long lens, wide angle lens, same location, different kinds of lenses. And then we have the invention of the cell phone. So here I found this comic, or this illustration from 1954. It's so ironic that here we are so many years later, and this is so true. I've had doctor visits on Zoom. Have you? I mean, it's so crazy. We're meeting, some of my classes are meeting on Zoom. This is a joke back in 1954, but now it's reality. We had giant cell phones. Look at that, the Motorola phone. And then here's a bunch of, razors and all these different cell phones. And then here's just a little joke. Back in the day, we were built to last, and now you look so fragile. Well, one must suffer to be beautiful. And then we're going to go over the history of the cell phone. This is a cell phone. Back in the day, here, I think this is President Truman making a phone call in his car. Here we can see radio cell phones. More car cell phones. Really fancy, extremely expensive. Here's another photograph. It looks very much like Star Trek. We have, it looks more like a radio than a cell phone, but we can see the numbers right here. The Motorola or brick phone. For one of the first touchscreen phones. Even Barbie had a cell phone. And I don't think, these videos are not going to work, unfortunately. You could have attachments onto your cell phone for different types of lenses. Nowadays, we don't really need that because our phones have multiple lenses already in them. But if you only have a phone with just one lens, you can buy more. Let's see. Okay, so different types of phones. Compare then to now. All right, so we're going to end the lecture right there.